All right, guys. Hey, so just wrapping up 8.2. Just in case people wanted to see how I worked some of the last few problems here, because I don't think I did 5B or 5C. You could pause the video and work through those steps if you think you need them. But anyway, we're going to cruise on to 8.3, graphing reciprocal functions. So reciprocal functions, you guys, in equation form are just 1 over, whatever a standard a of x function would be. So this says, it's in the equation of the form 1 over ax, where ax is a linear function and cannot equal 0. The reason that it cannot equal 0 is you cannot divide by 0. You get something that's undefined. Okay, so the parent reciprocal function, it looks like this. It is a type of hyperbola, which we are going to get into next chapter. The domain and the range are all non-zero real numbers. Okay, so it includes everything. The axis of symmetry is typically it is with the parent function. It is the x-axis and the y-axis. Okay, so it's symmetrical about both. And then the intercepts, there are none, because they're bound by those two things. And then they're not defined at 0, so they'll never cross the axis. Okay, so that means that there's an asymptote, right? So let me just clear these so that we can not be distracted as we go through these here. Okay, so an asymptote is an undefined area of the graph that the graph will always approach but not cross. Now that's not always the case, but with these vertical asymptotes it is the case. Whatever makes the denominator go to 0 is the vertical asymptote. Whatever the constant term is will be the horizontal asymptote. Okay? So basically, we have these areas on the graph. If I had like 1 over, for instance, if I had something like a 1 over x minus 1. Okay. If I were to plug a 1 into that, for x, what I would end up with is 1 over 0, and that's a place that's undefined. Okay, so on a graph, if I was graphing 1 over x minus 1, notice if I plug a 0 in there, I'm at -1, right? 1 over -1 is -1, so at 0, I'm at -1. If I plug a 1 in, however, I'm undefined. That is a place where this graph just will not cross. If I plug a 2 in, I get 1 over 1, which is 1. Okay, and then I could just keep going, but this graph will approach, like I could plug in things really close to 1, like 1.1 for instance, and it'll approach this dotted line. It'll just never touch that dotted line. So that's called an asymptote. Okay. So example 1 says determine the value of x for which the function is undefined. So they're just asking you what would make the denominator go to 0. So it's very easy. X cannot equal 1 in this case. In this case, it's not as easy to see. So what you could do is you could just say, okay, let's see what makes this thing go to 0. Let's set this to equal 0. All right. So if I do that, I get 3x is equal to -2. So x is equal to -2/3, and that must be it. So -2/3 is what would make that one go to 0. Okay, so that's example 1. Example 2, they want us to identify the asymptotes, the domain, and the range. So on this one, they gave us a nice picture. So basically, you're looking for the place where the graph just won't cross, like where it's approaching. So in this case, you can look at the picture here, and then you can confirm it with this. So this says that at 3, we have an asymptote, right? Because 3 is what would make this go to 0. That's a vertical asymptote. So whatever makes the denominator go to 0, that's vertical. That's a vertical dotted line that this thing will not cross. So it's saying that it's at 3, so let's see if that makes sense. This is 3 right here. All right, so those graphs are approaching that 3, but not crossing the 3. And then the other one appears to be at -2. Well, how does that relate to my equation? Well, my equation tells me that this whole graph got shifted down 2. So typically we have an asymptote at the x-axis. but we've shifted the whole thing down 2. Okay, so whatever this whole number is here on the outside of this equation for all of these, that's going to be the place where we have a horizontal asymptote. All right, so to answer the questions here, the asymptotes are at, so the asymptotes are at x equals 3, also at y equals -2. Okay, so that's my vertical and my horizontal asymptote. My domain is going to be, well, we can call it all reals. All reals where x cannot equal, so for the domain we're looking at the possible x values, so x just cannot equal 3. And then the range is going to be all reals, but we have one exception, and that's where y cannot equal -2. Okay, so the place where the asymptotes are is the place that it cannot equal. And that's it. So that's 2a. Now I'm going to encourage you to do 2b on your own. All right, so try out 2b here. And then I'm going to go ahead and do it. So for this one, notice what makes this go to 0 is -1. So x, so again, that's the vertical asymptote, right? So x is equal to -1. Okay, that is going to be the vertical asymptote, just to be clear. The horizontal one is going to be this guy right here, +5. So y equals +5. Okay, those are your asymptotes. Then the domain, all reals where x cannot equal -1. And then range is all reals where y cannot equal 5. All right, so that is 1 and 2. Now, from there, we've already gotten into some transformations here because these graphs shifted from the parent function. But now they want you to be comfortable with the transformations, and I always encourage students to go on Desmos. Go on Desmos, play with some transformations on these, and just see what happens when you plug different things into the parent function. But essentially what you have is whatever makes the denominator go to 0, that's how the whole thing is shifting, right? And then whatever's added is how it shifts. That's left and right because that's inside the function, by the way. And then the k is on the outside of the function. That's going to be shifting the whole thing up and down, which we just kind of saw. All right, so the a, the number that is in the numerator there, is going to help determine the orientation and the shape of the graph. So if the absolute value of a is greater than 1, then the graph will be stretched vertically. If it's between 0 and 1, it'll be compressed vertically. All right, and then obviously if we get a negative somewhere in there, that's going to flip things. So just remember that. All right, so steps to graphing this: identify the asymptotes, draw them in as dotted lines, plug in x values on either side to figure out what's going on, and then graph points until you get a similar picture to the parent function. Okay, so here we go. Example 3. So first of all, what makes the denominator go to 0 is -4, right? So at -4, we know that we have a vertical asymptote. Okay, so draw that in. Then the whole thing shifts up 1. So at 1, we have a horizontal. Okay, so that's kind of where my graph is going to be bound. Now I want to see what happens on either side of the vertical. Okay, so I want to look on either side of the vertical here. So let's go ahead and plug in a couple of things. If I plugged in a -3, notice what happens. We have -2 over -3 plus 4 plus 1. -3 plus 4 is just going to give me 1. So this is going to end up being -2 over 1, which is -2, plus 1, which equals -1. So at -3, notice that's when I plugged in a -3, right? -3, I got -1. So -3, I'm at -1. Okay. Then if I plugged in a, well, let's plug in a 0 just to see what happens over there. So if we plug in a 0, you'd have -1/2 plus 1, which is 1/2. So at 0, we're at a half. We're right in there someplace. So we kind of see what's going on over there. And actually, you know what? Since I know how this function acts, I kind of have an idea now that that's going to just keep approaching that asymptote. It's going to come over in here, and it's going to approach this asymptote, right? Don't make it cross like I kind of just did. So we have that kind of behavior happening, and if you plugged in something really close to -4, you'd see that, you know, you'd get a pretty decent size number. Then if we go on the other side of -4, let's just confirm here. So let's plug in a -5. At -5, we would have -2 over -5 plus 1 is negative. So if you have -2, sorry, over -5 plus 4, we get -2 over -1, which is 2. 2 plus 1 is 3. So at -5, we're at 3. All right. So we kind of get the idea of what's going on over here. Let's plug in though something else. Let's plug in a -8. So at -8, we're at a half, right? 1/2 plus 1 gives me, that's when I plug it into this. 1/2 plus 1 gives me 1.5. So at -8, I'm at 1.5. So somewhere right in here. Okay, so kind of the same deal happening up this direction. And we're done. Okay, so the domain is all reals. The range is all reals, but we have to limit that, right? Where x cannot equal. So in this case, my x value cannot equal -4. My y value cannot equal. Oh, did I do that backwards? Sorry, guys. My x value cannot equal. Oh no, that's right, -4. And my range, my y value cannot equal 1. There we go. And that's it. Okay.